Hello and greetings. My name is Leslie Sisdoni with metric number BK23110096, and right now I will be presenting about cost classification and behavior. Cost classification refers to the grouping of costs based on their nature and how they respond to changes in production activities. The table shows the cost classification and behavior of the costs involved in HVAC production at Inotech Manufacturing Limited. As shown in the table, steel casing and assembly labor are classified as direct costs because they are directly used in the manufacturing process. Both are variable costs since they increase as the production volume increases. On the other hand, factory rent is classified as indirect fixed costs because it supports the overall manufacturing costs and also it remains unchanged. Equipment maintenance is classified as indirect mixed costs because it consists of fixed maintenance repair and variable repair costs that depends on the machine usage. Meanwhile, electricity used in testing laboratories is classified as indirect variable costs because electricity consumption increases when more HVAC units are tested. Therefore, understanding the classification and behavior of these costs can help Inotech to improve their budgeting accuracy, control expenses more effectively, and also support better decision making. Moving on to section 2.0, I will now discuss the costing technique selected for Inotech Manufacturing Limited. For this study, the selected costing method is process costing. Why we choose process costing? It is because process costing is considered the most suitable costing method because the company manufactures similar HVAC units through a continuous production process. Since the products are produced repeatedly by using the same materials, labor, and manufacturing procedures, the production costs can be accumulated and averaged across all units produced. This provides a consistent unit cost and also help with cost tracking and reporting. To demonstrate the application of process costing, let's assume that Inotech Manufacturing Limited produces 1000 HVAC units in a month. Based on the monthly production cost table, direct materials cost 600,000 ringgit, direct labor costs 250,000 ringgit, and manufacturing overhead costs 150,000 ringgit. This production costs a total of 1 million ringgit. The cost per unit is calculated by dividing total costs over total units produced. Therefore, 1 million ringgit divided by 1000 units HVAC produced gives a total cost per unit of 1000 ringgit. In conclusion, process costing is an appropriate costing method for Inotech Manufacturing Limited because it reflects the company's continuous production and provides a consistent and reliable cost per HVAC units.
My name is Muhammad Hazim Iqbal bin Muhammad Jafar. So I will present about budgeting and forecasting. So for section 3.0, budgeting and forecasting are used to help Innotech estimate its expected sales, production costs, and profit before carrying out the first quarter expansion plan. The operating budget helps the company see whether the expansion of high efficiency HVAC units is financially practical. In this budget, the selling price is 2,500 per unit, the variable cost is 1,600 per unit, and the fixed cost is 450,000 for the first quarter. The forecast sales volume is 550 units. For the operating budget result, based on the operating budget, Inotech is expected to sell 550 HVAC unit in the first quarter. This will generate total sales revenue of 1,375,000 after deducting the total variable cost of 880,000. The contribution margin is 495,000. Then, after deducting fixed costs of 450,000, the company is expected to earn an operating profit of 45,000. However, the profit is still considered small, so the company must control material usage, labor efficiency, supplier prices, and customer order carefully. For 4.0 section, which is break-even and profit planning, so break-even analysis is used to identify the minimum number of units Inotech must sell to cover all costs. The contribution margin per unit is calculated by subtracting variable costs from selling price. So 2,500 minus 1,600 give 900. Then the break-even sales volume is calculated by dividing fixed cost of 450,000 by 900. Therefore, Inotech must sell 500 units to break even. At this point, the company make no profit and no loss. So, for profit planning scenarios, the profit planning analysis show different possible outcomes. If the company sells only 450 units, it will face a loss of 45,000. At 500 units, the company reach break even. The current forecast is 550 units, giving a profit of 45,000. However, if Inotech wants a stronger profit of 90,000, it needs to sell 600 units in the first quarter. For margin of safety and recommendation, the margin of safety is 50 units or 9%. This means Inotech's sales can only drop by 50 units before the company reach the break-even point. This shows that the company has a positive but limited safety margin. Therefore, Inotech should not depend only on the current forecast. The company should secure more purchase order, negotiate better material prices, reduce rework, and improve production efficiency to increase profit and reduce financial risk.
Hello and good morning everyone. I am Fahmi Hamizan and today I will be presenting on capital investment and project evaluation. So for this project, we are analyzing a capital investment of RM537939.42 for a robotic welding cell, which has an expected operational life of 15 years. So this system is projected to generate annual savings of 90,000, evaluated against a discount rate of 12%. To determine if this is some allocation of resources, we calculated the net present value. By discounting the 15 years of future cash inflow using our formula, we found the sum of NPV is 612977.80. After subtracting our initial investment, we get a positive NPV, which is 75,000. Because of NPV is greater than zero, it proves that this project will generate return above our cost of capital, making it highly viable. Next, we evaluated the project using the internal rate of return, or IRR technique. So the IRR is the precise discount rate where our NPV equals zero. So to estimate this manually, we can use an interpolation formula between two distinct range. We already know that at 12% discount rate, our NPV is positive. So if we test a higher discount, like 20%, the present value of our future cash flow will drop to roughly about 420,792.84, resulting in negative total net return. So because one range gives us positive value and the other gave negative value, we can deduce that our true IRR value firmly between 12% and 20%. For the second method, we use the Excel's IRR function across our 15-year cash flow timeline. So this provided an exact IRR of 14.55%. Looking at our final verification of decisions, both financial metrics strongly align. Our NPV is positive, meaning we are on track to fully recover our investment within the 15-year life cycle. Simultaneously, our IRR of 14.55% safely exceed our 12% rate. Therefore, from a financial standpoint, the project is recommended for acceptance as it directly supports production efficiency and long-term economic benefits.
So now moving on to my part, which is inventory and cost control. So for Inotech company, we have several types of inventory that we can classify. The first one is raw materials, for example, steel casing, copper tubes and wires, WIP, partly assembled hatchback units, finished goods, complete hatchback units, spare parts, or there are motors, sensors, machine parts, and consumables, which are welding wire, lubricant, and also packaging. So for inventory and cost control, we have to make cost control methods. So the common tools that we can use is ABC classification, JIT system, fee for usage, perpetual inventory system, barcode or QR tracking, and also cycle counting. So part 7.0, performance measurement and KPIs. I've made the proposed KPIs for Inotech. So basically there are 6 KPI. The first one is cost per unit, machine downtime, first pass yield, scrap rate, schedule variance, and supplier performance. So each of these KPI they have their own purpose. For example, cost per unit, it tracks production costs, and the impact is higher profit margin. For machine downtime, the purpose is to measure machine stoppage to ensure less lost production. For first pass yield, units pass without rework. This is the purpose, and the impact is lower defect cost. For scrap rate, measures wasted material, and the impact is lower material cost. For schedule variance, it tracks project delay, where it can make better budget control. Lastly, the supplier performance. The purpose is to check delivery and quality to make sure that there are fewer stockouts. So KPI also related to financial performance. So when we have better KPI performance, we can ensure that lower cost plus less waste and also high output. After that, it will produce higher profit and also better ROI.
Moving on to the next section, which is the project cost management, where we will look at how the execution of our project is tracking. So to achieve an accurate status update, we implemented Earn Value Management, EVM. Instead of just tracking expenses, this method helped integrate cost, schedule, and scope into unified metrics. By comparing what we plan to achieve against what we have actually completed and spent, we can objectively see whether the project is under or over budget and ahead or behind the schedule, using clear mathematical ratio like the CPI and SPI. So here, by looking at the EVM calculation and the Gantt chart, our baseline plan value for the project is about 1.33 million, combining our fixed and variable budgets. Currently, we assume that this company has physically completed 80% of the planned expansion activities, which yields an earned value of RM1064000. However, when calculating our metrics, our cost variance and schedule variance show clear warning signs. Our schedule variance stands at negative RM205100, which means that we are lagging behind our target timeline, while our overall cost variance highlight that we are spending past our projection, meaning to say we are over budget. So to break this down, we can look at our management dashboard and Excel cost tracker. At the first month, we were on budget but slightly behind schedule with an SPI of 0.95. So by month 2, our performance slipped further, dropping both CPI and SPI to 0.8. By month 3, our cumulative actual cost reached RM1349500 against an earned value of RM1.064 million. This leaves us with a final cost performance index CPI of 0.7 and the SPI of 0.8. Our project status is definitely classified as slightly over budget and behind schedule. as visually represented by our diverging cumulative S-curve. To sum it up, our project cost management indicate the expansion is currently experiencing critical cost overruns and schedule delays. Our negative cost variance of negative RM224600 proves that our actual expenditure exceed the objective value of the physical work that we have completed. Meanwhile, our negative schedule variance of negative 205100 indicates that we are trailing our baseline milestones. So moving forward, immediate corrective action are absolutely necessary. So we must implement stronger cost controls, review our labor and resource allocation, and optimize our schedule to have further overruns and bring this project back on track.
Hello, my name is Veronica with matrix number BK2311029, and I will be covering 9.0, which focuses on the decision-making tools used by Inotech Manufacturing to guide their strategic planning. Specifically, we will look at how they need to decide whether to outsource critical HVAC components or keep production in-house. To make this decision, two main quantitative tools are applied, which are the cost-benefit analysis and decision tree analysis. On the benefit side, the total benefits which come from saving on direct material, labors and testing lab utilities amount to 1.95 million ringgit Malaysia. While on the cost side, it includes the procurement, logistics and quality control, in which total is 1.375 million ringgit Malaysia. This gives us a benefit cost ratio of 1.42, where it means that for every 1 ringgit invested in maintaining in-house production, the company gains 1 ringgit and 42 cents in return. Therefore, outsourcing appears to be a financially viable option under stable market conditions. Now, let's move to the decision tree analysis. This tool considers that the market isn't always stable. There's a 95% probability of high demand and a 35% probability of low demand. For the in-house strategy, if demand is high, the company stands to gain 700,000 ringgit Malaysia. But if demand is low, they could lose 200,000 ringgit Malaysia. When we calculate the expected monetary value, it comes out to 385,000 ringgit Malaysia. For the outsourcing strategy, the payoff are smaller. High demand gives 450,000 ringgit Malaysia, while low demand still provides a gain of 120,000 ringgit Malaysia. The EMV here is 334,500 ringgit Malaysia. Comparing the two, the in-house strategy clearly delivers a higher expected value at 385,000 ringgit Malaysia versus the 334,500 ringgit Malaysia for outsourcing. So, from this perspective, keeping production in-house is the better long-term move, especially when we account for market volatility and the potential to maximize returns during high demand periods. Lastly, this is where the sensitivity analysis shows us the risk. The tornado chart and the sensitivity table tells us that the success of the in-house strategy is highly sensitive to operational efficiency. At baseline, the project's net present value is 75,038 ringgit 38 cents. But if annual cash savings drop just by 10%, which could happen if production becomes less efficient, the NPV plummets to only 13,734 ringgit 54 cents. That's a massive drop for a relatively small change in performance. In summary, the cost-benefit analysis shows outsourcing gives a good short-term return, but the decision tree analysis proves that in-house production is the better strategic choice in the long run, with a higher expected value and bigger upside during high demand. However, the sensitivity analysis is a clear warning, which in this case, the strategy comes with the significant risk if operational efficiency slip. Therefore, our recommendation is to proceed with in-house production, but management must treat operational control as a top priority. They also need to closely monitor performance, control costs, and protect the project from the volatility we have identified. That's all from us. Thank you.